Hi, Dr. Tracy here, part 3 of this section on bits and groups and bytes and numbers and everything else that's in here. But this last part in here to work on this week is memory. So why did they throw memory in with this decimal binary hexadecimal conversion? The reason is because now we have these components that we can talk to memory directly how memory works, which is in binary using hexadecimal notation so that we don't have to deal with those big groups of ones and zeros. But there's two kinds of memory that's going to be used for storing program instructions in the computer. There's random access memory and there's read-only memory. And random access memory is the one that we're going to use the entire time that the computer is working. A switch will either be set to 1 or 0, and it will stay in that state until it is turned off. So now you can see binary is just a big switchboard full. RAM is just a big switchboard full of binary, of switches that are turned on and off. They can read each state of the bit and change it. So the reason why it's called random access is because it takes the same amount of time to access any byte in the memory. We don't have to start from the beginning and then fast forward till we get to the middle. We can just go straight to the middle because we know its address, and its address is going to be also a binary number. That's a representation of its positioning within all of the elements that are within memory. Now, ROM, it seems like they're so similar because RAM versus ROM, but ROM really means read-only memory, and the bits are permanently set, and we can't touch them. So that's why it's random only. But you can think of memory as a very, very long array of bytes, and each one has an address, and each address is for its particular location. So when we specify memory, we're really talking about a particular location that's represented by a series of ons and offs. And having the particular address of a byte will never change, but we pull the value out and you use it within the program. And when we are going, and all of this plays into us being able to learn assembly, we talk in terms of hexadecimal. That's one shortcut that assembly was able to put into there. Instead of having to talk to a computer in its language directly, ones and zeros, we can at least talk to a computer in the language of hexadecimal, so we can use those digits to represent those memory locations, since there's literally millions of them, and we just don't want to have these big long things of ones and zeros. So if these bits are used to store data, then that means each of the places within memory, a 1 might be set or a 0 might be set, and we can pull them from their location. So this area is saying how many bits do we need to store certain things. Like, for example, how many bits do we need to store a letter grade? So we consider all the possible combinations of 2 bits. There's 2 bits we can have 0, 1, 2, and 3 is basically what that is, and that's only 4 possible combinations. And since a letter grade is A, B, C, D, or F, we need 5 bits. Now, so we use 2 bits in binary. We're using 2 pieces of memory, 2 little chunks, 2 little blocks, if you will. If the next thing we could go up from there is by going to 3 bits. Now, if we go to 3 bits, we find we can do 0, 1, 2, 3, 4, 5, 6, and 7. 1, 1, 1 is a 4, 2, and a 1, and it's the highest number you can go with 3 digits. But we don't need 7. We only need 5. However, that is the best bit pattern. So to store grades, I would need to use 3 bits of memory because I need to have at least 5 different options. And that kind of explains the way that something is going to work. We store information at memory that is given an address in hexadecimal. It's a large address because there's a lot of possible options, but it's working the same way as if there were a few. Now, in the exercises for the end of this part, you're going to figure out how much area of memory you would need to allocate for storing a certain amount of bytes. I hope this was helpful. Let me know if you have any questions. This is Dr. Tracy saying, hey, I will talk to you guys later.